this session from now. I think we stopped here, right, yesterday? Yes? We stopped in the second question.
Yes, Mr.
Is that no?
Yes, Mr. We are in the second one now.
Yeah. Now, yesterday some of you told me that you didn't understand this. So now here they are asking if a program has 10 instructions. So first 3 of them are 3 address. 3 address means what? Each address is what? Every address is 16 bit, right? So every this 3 address instruction will use 3 rows in your memory. And the next 5 are 2 address instruction, and the remaining are 1 address instruction. And the given base address is this one, and the segment address is this one. Now, what will be the physical address of last instruction? So, what are they trying to ask you now? Here is you have to draw it like this. So you will better understand if you draw memory. You're going to put a memory here. So you're going to give, this is memory row, each one row. Okay. Now what they say is you have 10 instructions. Okay. Of which first three are what? Read from
3 address.
3 address. Okay. 3 address means how it will be. Do you remember? We can say add R1, comma R2, comma R3. So this one you have your opcode followed by 3 others. So this will take always 3 because it is only 8 bit, each one byte, right? So this will occupy 3 address instruction will occupy 3 rows. That is, I will say this is I1, this is also I1, this is also I1. It requires 3 rows in your memory for what? A 3 address instruction. So the next 3 rows will be occupied by what?
I2.
I2. Okay. It goes on like this. So now, if I go like this, and share something else. Just give me a minute. Okay, let's see this one. What do you see now? Do you see Excel file?
Yes.
Do you see Excel file now? So now, let's consider this as the memory. Okay, this as the memory. I'm going to consider this as memory. I'm going to draw. Okay, so this is my. I'm going to put it in the center. So this one I'm doing it because you will understand better. Okay. Now here you have address. Okay. I told you this is going to be I1, right? Why 3 rows? Why 3 rows?
Because the first instruction
I2. So then I3,
takes 3 and
I3. So then next to 5 instruction, what happens? That's it. Next to 5 instructions are
two addresses.
5 addresses, 2 addresses. So what happened? I4, I4, I5, I5, then I6, then sorry. I6, I6, then I7, I7. Oh, then how many? 1, 2, 3. Are you right? I8, I8. Yes?
Yes,
Are you,
Mr.
are you with me?
Yes, Mr.
What are the last?
Yes.
What are the last 2 instructions? And the remaining of 1 address. So what
I9
is
and
I9, I. That's how the programs are stored now. Now what they have given you? They have given you the base address. The first instruction is 422D. Sorry, 422D. That's 4. This address they have given, and they have given you a segment address. What are the segments? S, DS, SS. They have given you the segment address. Segment address is 5EEA. Okay, because of this program, it will be here 5EEA. Is that correct?
yes, Mr.
This is the question, right? This is given, but they are asking you to find the physical address of last instruction. You need to find the physical address of this instruction. Now, how do you find the physical address of first instruction?
We will add the address with the
How you will do? Equal to, so you will first multiply CS into 10, right?
10.
So then that means 5 EEA multiply 10, okay, which is equal to how much? 5 EEA 0. You understand? So this address, you are going to add your offset address 422D. What happens now? If you add, what happens? How much?
Then we will add the result
Tell me how
with,
much.
we will
much?
add
So you
5
have
EEA with 4 to 2D.
So A plus 2, how much?
4 to 4.
A plus 2 is C. E plus 2 is yes, 0. So 0. Then E plus 4, how much? E, F, 1, 0. Tell me. E plus 4, 4, 1, 0, 1, 1, 1, 2. So 1, 2 plus 1 already you got 3. So it will be 3 now, 1 remaining, 4 plus 1 is 5. Is this correct? So the physical address is this one. Is the addition correct? Can you check is the addition correct?
What about remaining ones? Yeah.
Remaining one I added, no? Okay, it is, I'm sorry, it should be 6, right?
Yes.
Okay, 630CDH. Is this correct answer correct?
Yes.
Yes. Now, but this is what, this they did not ask you. They are asking you for this one. They are asking you for this one. How to know this one? How do you know the address of this one? Anyone?
Mister, you said the address always the memory it's become with the sequence. So we need to calculate the number of address and it will become
Very good.
21
So
and then we will
this should be 422 E. Okay.
yes.
Plus 422 42 what? 30. Is it correct? How 2F and then 30 how it comes?
Because after if we have 1 0.
1 0 0 and 1 goes carry 2 plus 1 3. So next one is 4 2 3 1 4 2 3 2 then 4 2 and drag actually up to 9 you can drag. Okay, what is the next value? 4 2 3 A. Yes. Girls, are you there with me or no?
Yes.
Then 4 2 3 B. 4 2 3 4 2 E. F. What is next one? You have to tell immediately. 3F and 4 0 on this one. Correct? Is it correct?
Yes.
Okay. Aisha Makbali. Now, find the
Yes,
address of last instruction.
Now we should add. Yes, sir. I should add 5 EEAS with
Yeah.
4 2 5 EEA 0 with 4 2 4 1. I can't see.
What's the answer?
4 2 4 1.
What's the answer now?
0 with 1 0.
Then A plus 4.
A with 4.
B, C, D, E. E, right?
Yes. Yes.
Then E plus 4.
E plus
E,
2.
F, 1 0, 1 1, 1 2. So you write 2, right? 2
Yes,
here.
one
And
and the remaining one.
2 or 3.
Yeah.
Is it correct? 2 or 3? Four, 1 and 1.
E with 4.
First one. A plus 4 is E, right? 620 E1. Is this correct?
B, C,
No,
D, E.
63.
Yes, yes,
But
yes,
here
E.
how 63 came.
Okay.
Here D, this is A, B, C, then A plus 2, then E plus 2, 0, 1. Okay, we had one carry there, that's why. Here 620 E1. That's the physical address of last instruction.
Okay.
So this is one method. The other method what you can do is you don't have to write all this one. What you know the address of the first instruction is 422B. So now how many instructions are there? 10. In 10, first 3 instructions are 3, right? So you have 3 into 3, first 3 instruction 9, right? Next to 5 instructions, 2 address, 2. Then you have 1 plus 1. Yes or no? Do you understand
Yes,
this one?
Mr. Yes, Mr.
3 instructions, okay? Then 5 instructions. Then last 2. Okay? 8, this is 9th instruction, this is 10th instruction. So first 3 are 3 address, so I'm going to give 3 into 3, 9. The next one is 2, 5 into 2, 10. So total how much here? 19, 20, 21, right? Total 21, yes or no?
Yes, Mr.
Yes.
Right.
So what you do is, you can add 4 to 2D plus how much?
21, but we have to convert it to
Yeah, we have to
hexa.
convert, very good. We have to convert hexadecimal. What is hexadecimal of 21? Anybody? 16 is 10, 17 11, 18 12, 19 13, 20 14, and 21 is 15. So you're going to add 15 to it. So now what happens now? How much? Add and tell me. D plus 5 how much? E, F, 10, 11, 12. So 2 you're going to put, and then you're going to have one carry, right? 2 plus 1, 3, that will be 4. And then remaining it will be like this. 4, 2. Okay. Actually, you have to reduce one because you're going to find the address of this one, right? Yes or no? You're going to find the address of this one. Well, are you okay? So this should be 20, not 21. You have to take 20 and this will be I 14. So this will be correct one, 41, 42, 41. Do you see this one and this one is matching now? See, both method you can do this method or you can do this method. It's very easy you can do. You understand?
Sir, sir,
Yes.
why we add 14?
Why you add? This one 20, hexadecimal of 20 is 14. Hexadecimal of 20.
Okay.
16 is 10. Then 17 is 11. 18 is 12. 19 is 13. And 20 is 14. Hexadecimal equivalent. Okay? Do you understand?
Yes.
Okay, you want to write it
Yes,
down?
we don't like what you do in the last by add the instructions and some the instructions and then add the hexadecimal. It is okay?
It's okay. It's okay. You don't have to. Unless otherwise they are going to ask you for all the physical address. If they are going to ask you all the physical address, then you have to find all. Okay.
Okay, sir.
So we'll go to the next one now. Now the next one is special purpose registers. So these are some very special purpose registers, that is that you and me, programmers, cannot use it, only for the use of the processor, only for the use of the computer. Those processing registers are called as special purpose register. The first one is instruction register. You know what is instruction register, right? Instruction pointer or the program counter. So this is also called a program counter. It is going to point to the next address of the next instruction that is going to be executed. Okay, the next one important is flag register. So this flag register is 16-bit register. It has different flags. Like I'll show you from the picture. This is the flag register. You have 0 to 15, that is, it is 16-bit. There are different carry bits. 0th flag, the 0th bit is carry flag, parity flag, auxiliary flag, zero flag, sign flag. This is trace or trap also they say, interrupt, direction flag, and overflow flag. Now I'm going to explain to you what is what. Okay, like for example, carry flag. If there is a carry, when you do any arithmetic operation or any operation in your program, if there is a carry, resulting value as a carry, then this flag will be set to 1. Okay, let's see an example. I'm going to have okay, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 14, 15. So that means I have how many? 16-bit. Are you with me? Are you with me? So
Yes,
carry.
Mister.
So this is going to be, we are going to call it as carry flag, parity flag. I'm going to explain to you one by one, okay? This one, a auxiliary flag, then zero sign, zero.
Mister, I cannot hear you.
I'm not talking anything, I'm only typing.
Okay, Mister.
Okay. Now this is okay, this is called flag register. This is called 8086 flag register. So now what happens? This is called as status flag. They also called as status. What do you mean by status? It is going to tell you what status after every operation. What is the status? Like for example, I'm going to have to add L comma 0 5. Move BL comma 0. Okay. Now what happens now? Tell me. I have my register. This is AL, BL, CL, DL. Register. What happened now? 0 5 will go here, and then 0 2 will come here. Yes? Are you with me?
Yes,
Now,
sir. Yes,
going
sir.
to add AL comma BL. You understand? So now what happens? Add AL comma BL. It will add AL and BL and put the value in 7. You understand? Now, after every instruction, after any instruction that is executed in your CPU, this status flag will be updated. Updated. It will be set to 0 or 1. So each bit can hold 0 or 1. Are you with me? This can be 0 or this can be 1. Not any other value. Are you with me, girls? So now, after every instruction, this is going to be. Now, for example, after add, this will be updated. So, first thing that it will check is whether it has a carry or not. What do you mean by carry? What is 0 5? 0 0 1 0 1. Okay. Sorry, put in text. 0 1 0 1. Okay. What is 0? What is 0 2? Is 0 0 1 0. Yes. Girls, you're listening or no? Are you listening or no?
Yes, yes, yes.
Okay. Now when you add, what happens now? 0 1 1 1. Yes. This is my answer. Yes or no? I don't know whether if you say yes or no, only I can continue.
Yes, sir, yes.
Okay. Now in this one, in this result, do you have a carry? Do you have a carry?
No.
What is carry? If there is a carry outside, then we call it a carry. But here there is no carry. So the carry flag will become 0 after this. Do you get me?
Yes, mister.
Okay. When will carry
Yes.
be set? Like for example, I'm going to have 0 5. Now I'm going to move this to 5. What happens now? Now it is 0 0 1 0 1 then 0 1 0 1. Now check what is the answer. 1 0 1 0. Do you have carry? Again, no carry, right? Yes or no? No carry.
Yes, no.
So this will be again equal. Again, if I'm going to say move AL comma A1 and move BL comma 1 0. Now what happens? Tell me. What is A1? 1 0 1 0 then 0 0 0 1. Yes. What is 1 0? can change this value. BL can be 9 2. Okay, what is 9? 1 0 0 1 0 0 1 0. Sorry, 1 0 0 1 0 0 0 1 0. Yes. AL and BL, correct or no? Now if you add, what happens? If you add, what happens?
1 0 0 1.
You add it from the back side, okay? So 1 plus 0 is 1. Okay. Then 1 plus 0 plus 1. Then 0 0. Then space. Then 0 plus 1 is 1. And 1 plus 0 is 1. Then 0. Then 1 plus 1 is 1 0. 0 comes here. Now there is 1 carry. Yes or no? When you add these two, do you have a carry? Oh my god, girls, you are there or no? Do you have a carry?
Yes, 1.
Now, what happens here? Carry flag will become now 1. See, it is very simple. After any addition or subtraction or multiplication or do any arithmetic operation, if there is a carry, then this carry flag will become 1. Otherwise, the carry flag will become 0. Someone there or no? Only Aisha Makbali is there. Others?
Yes,
Do you understand? Aisha Khalid? You're all there or no? Kautar, do you understand? Do you understand?
I
Carry
try to understand because yesterday I didn't jump. That
This
is
is not depending on yesterday. This is totally a new topic.
yes.
Okay. It's a register, flag register, 16-bit flag register. There is something called carry flag. When this will become 1, when this will become 0. After any arithmetic operation, if there is a carry, then carry flag will become 1. If there is no carry, then this will become 0.
Yeah.
Okay. Right? Now next one is parity. Okay, next one is parity. I told you first we'll see carry flag. Carry flag. If there is the carry, then CF equal to 1. Otherwise, 1. Do you understand carry flag?
yes, Mr. Yes,
If
Mr.
there is a carry after any arithmetic operation, then this is going to be 1. Now, parity flag is after any operation, the number of parity flag equal to 1. What do you mean by this one? Tell me. After any operation, if total number of ones This total number of ones. Ones. See, after any operation, you have to count the number of ones. Like for example, let's take this example, okay? Let's take the same example. You are adding add L, DL. Now here you are adding. This one will not be there. This is carry, okay? Now here in the result, how many ones are there? How many ones are there in this result?
Six ones.
Right? 6. Yeah? So 6 is odd or even?
Even.
Even. So tag will become 1. Do you understand? Okay. Let's see another example. AL, B2, A. Okay. Add AL, BL. Now tell me what happens. Tell me now. What is AL? B2, what is B2? How to write B2? Girls, I think you are not listening at all. What is B2 in a binary? See, if I write everything, then I can teach. When you will not.
Sir, D is 1 0 and 2 0 0 1 0.
Now, what is 0, 1, okay, 1, 0, 1, 0. Is it correct now? Total, how much is total? I'm going to put 0, then 0 is
0,
1,
0, 1,
carry 1. So I'm going to put 0 plus 1, then 1, then
1, 0, carry 1,
carry 1, then 1,
0, carry 1,
carry 1,
1,
then 0, then carry 1, then 0. So you have 1 carry here. I'm sorry. 0, this is again 0, then you are going to have 1, then you're going to have some space, then you're going to have 0, then 1, then 0, then
0.
0.
0.
But you have 1 carry here, right? So carry flag, what happens after this instruction? Carry flag will be set to 1. What happens to parity? How many
1.
1?
3.
How many 1 is it? 3.
No, no, 3. It will be 0.
So this is
0 because 0.
and this both flags should be updated. Actually, every operation, every flag will be updated because I'm teaching you one by one. I'm updating these two. Do you understand?
Yes, mister.
Okay. The next one is auxiliary. Auxiliary flag here. Now, in this auxiliary flag, what happens is that it will check. Do you see this one? 4-bit. How many are
Yes, mister.
first 4 and second 4, right? First nibble and second nibble, yes? Yes, sir.
Yes.
So, if there is a carry from the lower nibble to higher nibble, then auxiliary flag will be 1. Okay? If there is carry from lower nibble to then AF equal to 1. Otherwise, I mean, so when I do this one, 1, 2, 3, 4. From 4th bit to 5th bit, if there is a carry, AF will become 1. If there is no carry, AF will not be 1. Now, see in this example. We'll see this. Do you have auxiliary flag? What will be set here? 0 plus 0, 0. 1 plus 1, 0. Here 1. So 1 here. This one. Do you have a carry there? 4th bit to 5th bit, do you have carry?
Yes.
Yes. 4th bit to 5th bit, I'm asking. Which is 4th bit? This is 4th bit, right? Do you see my mouse pointer?
Yes.
4th bit to 5th bit, do you have a carry in this example?
No.
No, mister.
No carry. So this will become 0.
So we have to check in 4 and 5th bit, mister?
Yeah, that is lower nibble to higher nibble.
Okay.
Nibble is 4-bit, right? Nibble is 4-bit. 4-bit
Yes.
is nibble. 8-bit is byte. Okay, this is auxiliary flag. 0 flag. The next one is 0 is very simple, but it is very confusing. If okay, what do you mean? If the result of any operation is 0, then 0 flag will be 1, otherwise it is 0. So in this operation, what is 0 flag? 0 or 1? In this last example,
Mister, repeat.
see, I don't have to repeat, you can read this one. Read this one. Read this one. If the result of any operation is 0, see, when you add, you subtract, you multiply, if the result is 0, then 0 flag is 1. Otherwise, 0 flag is 0.
It will be 0.
Now, is the result 0? Non-zero, right? So this will become 0. Do you understand? Let me give you an example now. Right here. AB. Now, what happens here? What happens here? AL comma AB. Move BL comma AB. Subtract AL minus BL. What will happen? What is AB? 1010 space 1011. Yes, yes or no? What is this AB? 1010 space 1011. If you subtract, what will happen? What will be the result if you
It
subtract?
will be 0.
0, 0, 0, 0, so 0, 0, 0, 0. So in this example, now this is the example. Now tell me what are the carry flag, what are the all these flags? What will be carry flag?
0.
0.
Parity?
Mm, 0.
0.
0 is even number or odd number?
Even 1, 1.
0 is even number, right?
Yes.
Then auxiliary, 0.
0.
Okay, 0 flag?
1.
Very good. 0 flag will be 1. Do you understand, girls? 0 flag.
Yes, mister.
Yes, mister.
Next one is sign flag. Sign flag. Sign flag is very easy. If the result is negative, then sign flag equal to 1. Other flag equal to 0. How do you know that result is negative or positive?
If we subtract
No.
small.
Very easy technique I'm saying, okay? Don't forget this one. I'm going to tell you a very easy technique. Technique is if most significant bit, then the number is most significant bit is 1. Here, which is the most significant bit? Do you know
1.
which is significant and least significant? No. See, I'm going to write. See here, which is most significant? This is the least significant. This is most significant bit.
Yes.
Okay. Now here, which is least significant bit? 1. What is most significant bit?
0.
0. So number is positive or negative?
Negative.
Positive. 0 is
Positive.
if the last value is 1, it is negative number. You understand?
Yes.
Okay. Here, positive or negative?
Yes, mister.
Positive.
Okay. This
0.
is positive or negative?
Positive.
Positive.
So here, what will come now? This is the last.
1.
Positive.
This is the last operation we did.
No. 0.
0 because it is not a negative number. If it is a negative
0.
number, it becomes 1. You understand? Do you understand?
Yes, mister.
Yes, mister.
Okay. Trap. This is trap or trace flag. This is nothing but we are not going to do any calculation. Like in your program, like C++, Java, when you do step-by-step compilation. Do you remember? Line by line, it will execute. You press F4, F4, F1, F1. Do you remember? Line by line, you are executing. Are you with me?
Yes, yes.
Trace is you are tracing first line execute, the second line then execute, third line you execute. So you hold only when you press enter, it will go to next line. That is called trace. You are not going to do anything, just understand. Interrupt is there are different interrupts in your 8086. If the interrupts are enabled, this will be 1, otherwise it will be 0. This is DF is direction flag. So direction flag will be from left to right and right to. You can write left to right and right to left, right? Both. So whichever direction you want, you can set. 1 is left to right, 0 is right to left. And this is overflow. This one you should know. Overflow. Overflow is if the result is bigger than your register, then it is called as overflow. Do you understand? Do you
Mister, repeat.
result is bigger than your register, then OF equal to 1. Otherwise, OF equal to 0. See, you are going to multiply two 8-bit value. It is going to result in 16-bit value. Then it is called overflow flag. Multiplication will result in making the number big, right?
Yes.
So those cases are called as overflow. If the registers are 8-bit and the result is more than the 8-bit, then overflow will be 1. Otherwise, here in all the cases, overflow is 0 only. So this is what is flag register is. You have to remember this one: carry flag, parity, auxiliary, zero, sign, and overflow. Do you understand? Carry flag set is 1 if there is a carry. Parity will be set if the result of 1 is even. Auxiliary is if there is a carry from 4th bit to 5th bit. If the result is 0, then carry flag will become 1. If the result is non-zero, carry flag will be 0 flag will be 0. Sign flag, if the result is negative, sign flag will be 1. If it is positive, it will be 0. Overflow flag, if the result is bigger than the size of the register, then this will be 1. Otherwise, it will be 0. Do you understand? Now, that's what they explained here. If you read this one, if you read one by one, this is what they explained here. You understand?
Yes, mister.
Yes, mister.
Okay. Now, exercise. If a flag register has a value E53A, then which flags are set?
There is no operation.
No, if the flag register has a value, they put the value, right? E53A.
Ah,
So, you have to put here E5. What is that? E53A. Is it correct? Yeah. E53A. So, what is E? So, remove all the values from here.
14.
E.
14?
Yeah, what is the binary?
Ah.
1110.
What?
0.
310.
5. 0. 0. 1.
0101.
1. Then 3. 0. 0.
0011.
The last one is A. 1 0 1 1
1010.
0 1 0. Now they are asking you what are the flags that are set. The question is, if flag is missing, then which flags are set? Which are the flags that is set? Auxiliary is set. This one, trap direction is set. Only these flags are set. Others are not set. Do you understand the question?
Yes.
Yes, mister.
So
Yes.
your answer is DF, TF, and AF. This one homework, okay?
Okay.
This is homework. You have to do it as homework now.
Okay, mister.
These are some exercise also. You can check. Okay, try to solve it. So we finish this topic. Do you understand? Did you write all this one, or you need time to write?
Mister, we need time.
Okay, right.
Can you increase the phone?
Okay.
Or more, mister? Make it bigger.
Is it okay?
Yes. Can you go down? Yes. Okay now.
So what is the next topic that we need to discuss?
Mister, can you go up? More, Mister. Okay. Mister, I finished writing.
Okay. Now I'll upload this PowerPoint to your where I will upload to your e-learning. And then you can do those exercises now, okay? Or shall we start the next topic?
No, Mister, we want to do exercise.
You want to do exercise?
Yes.
Okay. It's just to hold on. Okay, did you find in the e-learning? Programming the CPU.
Here,
Hmm.
I cannot log into the e-learning. I don't have
Why?
Wi-Fi.
You don't have Wi-Fi? Only today or?
No, today, just today.
Okay, I'm just uploading. Maybe you can later. What else you want me to do? Shall I upload it in your Shall I send it to your mail? Aisha Makbali.
No, sir. Can you send to my WhatsApp? Maybe I cannot open PDF
You can
or image, sir. Image picture.
no problem. You can do it later, Aisha. Okay. I am putting it
Okay.
in e-learning. You can later do it. Okay.
Okay.
I put it in the top announcements. All it's there in the top only. Okay. All the materials are in the beginning. You don't have to go to weekend search. Okay. Programming the CPU. I put. So solve it. You can. So we'll finish the class now. Okay. Anything you want to ask? Is there anything? Girls.
No, Mr.
Okay, so we'll stop.
No, Mr.